Welcome to the course on Introduction to Advanced Power Electronics. Myself, Professor Bhim Singh. The outline of the today lecture is course objective, course structure, and plan of evaluation, and textbook on power electronics. Coming to the course objective, this course includes advanced topic of power electronics such as some of latest devices and their control and application. To understand the advanced solid state devices, thermal design, protection, gating circuit, digital signal processor used in their control, to understand the concept of RL and power factor in single phase and three phase supplying nonlinear loads, to understand the non-isolated and isolated DC-DC converter and their applications, to understand the power quality improvement in improved power quality AC-DC converter, switch mode power supply, uninterrupted power supply, drive system, lighting systems, and renewable energy system. Now coming to the course structure, the course is planned with first part of the course is power electronics devices and introduction with 2 lectures on advanced solid state devices like MOSFET, IGBT, GTO, and IGCT. Then wide gap devices, silicon carbide and GaN devices. Then power modules, intelligent power modules, gating circuits, and design of snubbers, thermal design protection, digital signal processor used in their control. The second topic, which consists again couple of lectures on chopper and non-isolated DC-DC converters. So in choppers we will cover step down, step up choppers, then class B, class C, class D, and class C and multi-phase choppers. And for non-isolated DC-DC converter we will cover like buck converter, boost converter, buck boost converter, cuck converter, SEPIC converter, Zeta converter operating in discontinuous current mode as well as continuous current mode. Now the third topic, which I have on 3 lecture on isolated DC-DC converter and power factor correction converters. It will consist of isolated DC-DC converter consisting like flyback, forward, cuck, SEPIC, Zeta, half bridge, push-pull, bridge in DCM, and in discontinuous current mode and continuous current mode. Then single phase, single stage converters, power factor correction in at AC means in these converters, applications in switch mode power supply, uninterrupted power supply, weldings, lightings, and EV charging. Then fourth topic on which we have 4 lectures on power quality and introduction to power quality monitoring, instrumentation and regulation, static series and shunt power electronics voltage quality controllers, then modern arrangement for reduction of voltage fluctuation, and then active power line conditioner. Then fifth topic is multi-phase converter and HVDC system with 2 lectures with the introduction with 12 pulse converter based HVDC system and multi-pulse and multi-level voltage source converter based flexible HVDC system. Then the sixth topic will have a improved quality AC-DC converters with 4 lectures with on single phase improved power quality AC-DC converters with buck boost and buck boost category and PWM voltage source converters, then multi-level voltage source converter and PWM current source converters. Then 7th topic will cover 3-phase and multi-phase improved power quality AC-DC converter with 4 lectures with 3-phase improved power quality AC-DC converter consisting of voltage source converter, multi-level voltage source converter, and multi-pulse voltage source converter. Then we will discuss PWM current control voltage source converters, and then multi-pulse AC-DC converter with diode and thyristor based converters. Then 8th topic will cover multi-level converters with the 3 lectures will consist of multi-level inverters and their control and detailed PWM analysis and multi-level inverters, and then modular multi-level converters. Then the 9th topic will cover multi-level inverter drives with the introduction to multi-level inverter fed induction motor drives, then harmonic suppression and multi-level modulation technique for multi-pulse converter fed multi-level inverter based induction motor drive, then power quality improvement in multi-pulse converter fed multi-level inverter based induction motor drive. Then we will have the 10th topic on resonant converters with the analysis and principle of operation of resonant converters, then series and parallel resonant converters, zero voltage switching resonant converters, then zero current switching resonant converters, and quasi-resonant and multi-resonant DC-DC power converters and phase control resonant converters. Then on 11th topic we will talk about solid state control for motor drives with on solid state control for motor drives such as vector control and direct torque control of induction motors, synchronous motor, permanent sine fed motors, and synchronous reluctance motor. Then we'll cover permanent brushless DC motors and switch reluctance motor. Then LCI fed 12 topics, LCI fed synchronous motor and power quality improvement of drive with the load commutated inverter fed large rating synchronous motor drive, and then energy conservation and power quality improvement in these drive. So this covers the complete course. Now we have a plan of evaluation which consists of majorly 2 component assignment. So we'll have a total 8 assignment, out of which best 6 will be taken of 25 marks, and main exam which have a 75% weightage have a 70, and total marks will be out of 100 like. Now coming to on textbook on power electronics. So these are the power electronics, starting the latest book on this M. Rendell and Cho on software defined power electronics by Columbia University in 2024. Then Professor Jayant Balikabu, the IGBT devices, physics, design and application of insulator gate bottle transistor in 2022. And the power electronics handbook in 2023. So these remaining, of course, are the further like J. Kasasian and Principle of Electronics, 3rd edition, Cambridge Press 2022, followed by the other books. And we have a large number of books in this subject of electronics, which have been for probably last 50 years. And thank you very much.